At over 300 kilometers per hour on the Bahrain main straight, Lewis Hamilton's rear wing turned upside down. Not partially, not subtly, completely inverted. For a split second, the surface that had been forcing the car into the asphalt was facing the sky. Engineers on the pit wall froze. Sky Sports thought the car had broken. Rival team personnel physically walked down the pit lane to stare at it. But what almost nobody connected in that moment was this. The upside-down wing was not the real innovation. The real weapon had been bolted onto the car 24 hours earlier, and without it, that wing would never have made sense. If you appreciate deep technical breakdowns like this, make sure you hit like, subscribe, and turn on notifications. There is a lot more hidden inside the 2026 regulations, and we are unpacking it piece by piece. On day one of the final Bahrain test, Ferrari quietly installed a small aerodynamic device directly behind the exhaust pipe of the SF26. The cameras barely lingered. It was compact, almost anonymous. Day 2 was different. The rear wing rotated around a central pivot between its two upper elements and continued past every conventional stopping point. Not an angled compromise like Audi's, not a trailing edge stall like Red Bull, McLaren, or Mercedes. A full 180-degree rotation. The flap assembly flipped completely upside down. 9 of 10 teams had interpreted the new active aerodynamic regulations in nearly identical ways. A trailing edge pivot, a predictable stall, a familiar DRS evolution refined over 15 years. Ferrari did something else entirely. They didn't reduce drag by weakening the wing. They eliminated its aerodynamic identity altogether. When inverted, the profile shifted from downforce generator to aircraft-style low-drag surface. Convex on top, concave underneath. Instead of compressing the rear tires into the track, it minimized resistance and possibly produced a trace of lift. At 340 kilometers per hour, the paddock reaction told you everything. Craig Scarborough reportedly checked whether it was April Fool's Day. Sam Collins believed he was watching a mechanical failure, but that wasn't the real story. The regulations mandate that the full transition must occur within 400 milliseconds, less than half a second. That is the window Ferrari has to rotate 180 degrees twice per straight, once opening, once closing, while the car approaches braking zones at over 300 kilometers per hour. During rotation, the wing passes through a vertical position. For an instant, it becomes a flat surface perpendicular to airflow, effectively a sail, a transient drag spike that hits twice per activation. Other teams avoided this risk entirely. Their trailing edge pivots allow airflow pressure to help snap the flap closed. Faster reattachment. Predictable aero balance. Ferrari accepted instability in exchange for scale. Early telemetry from Hamilton's 5 laps suggested a potential 10 km/h straight-line gain on the Bahrain straight. Small sample. Caution required. But directionally clear. Paddock estimates placed the combined advantage of the flip wing and exhaust flap at roughly 15 hundredths to 25 hundredths of a second per lap. On a 57-lap Bahrain Grand Prix, that compounds. But the top speed figure is only half the calculation. Reduced drag means reduced battery deployment required to reach the same velocity. That preserves electrical energy for corner exits, defensive bursts, and final stint attacks. This is not just aero, it is energy strategy. And that shifts the conversation entirely. 9 teams read the same rulebook. 9 teams chose safety. Trailing edge pivots allow airflow to assist closure. Brake at 300 kilometers per hour. Wing snaps down. Rear stays planted. Audi split the difference. Pivoting mid-end plate, rotating to an intermediate angle. A compromise between stall and diffuser interaction. Alpine went aggressive in a different direction. Leading edge pivot. Trailing edge folds downward. But engineers reportedly noted slower flow reattachment. Gary Anderson observed that Alpine's camber change system requires re-energizing airflow during closure. Less predictable. Ferrari rejected all of it. They designed the SF-26's rear architecture around end-plate-mounted actuators instead of a central pod. They removed the visible central actuator seen on earlier test versions. They accepted packaging complexity that others avoided because they weren't solving a wing problem. They were solving a system, and that system began with something smaller, the FTM, a small aerodynamic element mounted directly behind the exhaust outlet. Internally named, quietly deployed, it performs two functions. First, it redirects hot exhaust gases upward, energizing airflow toward the underside of the rear wing. Second, it extends diffuser suction, increasing rear downforce in corners, more grip, more stability, more drag, unless you can erase that drag on the straight. Ferrari chose a smaller Garrett turbocharger than rivals. That leaves more exhaust energy available aerodynamically. Their exhaust tailpipe is the smallest on the grid, increasing gas velocity. They pushed the differential rearward to create space under the crash structure for the device. This was not an add-on. It was baked into the gearbox, suspension, and crash structure months earlier. Under current power unit regulations, the combustion engine must maintain high revolutions even in lower gears to support the electric system. That means consistent exhaust flow through medium and low-speed corners. Unlike the 2011 exhaust-blown diffuser era where lifting off killed the effect, this system persists. Now the pairing becomes clear. The exhaust flap increases corner downforce, the flip wing deletes straight-line drag. Individually, each carries compromise. Together, they cancel each other's weaknesses. And that is the amplified effect other teams did not calculate. Engines and transmissions are homologated. You cannot redesign turbo size, exhaust routing, or gearbox architecture mid-season. The FTM requires different turbocharger philosophy, different exhaust geometry, different differential placement, different rear crash structure layout. Crash.net reported that copying the rotating wing would require redesigning the entire rear end of the car. End plate mounted actuators, structural reinforcement, load path recalculation, suspension interaction, crash compliance. This is not a wing update. It is a car philosophy. When McLaren team principal Andrea Stella walked down the pit lane to inspect the SF-26 personally, it was not curiosity. It was recognition. One of the architects of 7 championship-winning Ferraris wanted to see it up close. That tells you how seriously the paddock is taking this. Consider the race distance, 57 laps in Bahrain. If Ferrari saves even a small percentage of battery deployment per straight due to reduced drag, that compounds into meaningful energy reserve. Energy that can be deployed, exiting turn 1, defending into turn 4, attacking in the final stint when tire degradation peaks. The SF-26 has already completed over 4,300 kilometers in testing, roughly 14 Grand Prix distances, without major reliability issues. The flip wing ran for 5 laps before being withdrawn. The exhaust flap ran extensively. Even if the rotating wing does not appear at the Australian Grand Prix on March 8th, the exhaust system alone remains race-ready. The wing is classified as a test item, but the architecture is not, and that is the deeper signal. Lewis Hamilton said this car contains some of his DNA after 10 months of simulator development. After a season without a podium, that statement carries weight. Ferrari did not iterate cautiously. They did not mirror Red Bull. They did not follow Mercedes. They found a freedom in the regulations. No maximum rotation angle, no direction constraint, no requirement to remain upright, and pushed it to the mechanical limit. A 180-degree reinterpretation of the rulebook. If the transition proves stable within 400 milliseconds, if the sail effect is manageable, if drivers trust the rear under braking, then Ferrari will not just have built a fast wing, they will have built an integrated rear-end system where turbo, exhaust, gearbox, diffuser, and wing operate as a unified aerodynamic weapon. That is not experimentation, that is intent. What we witnessed in Bahrain was not just an inverted rear wing, it was a demonstration of architectural conviction. 9 teams optimized components. Ferrari optimized interaction. The flip wing alone is risky. Vertical drag spikes, packaging complexity, flow reattachment concerns. The exhaust flap alone adds drag, but together they reshape the fundamental trade-off between corner grip and straight-line efficiency. 15 hundredths to 25 hundredths per lap may sound marginal. Over 57 laps, it becomes decisive. The SF26 has already proven reliability across 4,300 kilometers. The foundation is stable. The concept is legal. The philosophy is deliberate. And crucially, it cannot be replicated mid-season. This is not an update cycle. This is a structural advantage. The only remaining question is not whether it is clever. It is whether it is controllable under race pressure. Because at 300 kilometers per hour, as the wing rotates through vertical and the driver commits to the braking zone, trust matters more than innovation. If Ferrari has solved that final piece, have we just watched the opening move of a championship campaign built not on imitation but on interpretation?